Hi there. This is going to be the video recording for Chapter 1, Lesson 4, Quadratic Equations and Applications. So if everybody would please open up their textbook to page 100, we will get started. Alright, so in this section we're going to be taking a look at solving quadratics in three different ways. We're going to solve by factoring, and there's several ways in which to solve by factoring, so you'll see many examples dealing with that first method. The second method is to solve by graphing, and this mainly we're going to be looking for x-intercepts because those intercepts will be where the values of y on our parabola or our graph are equal to 0, and it is those zeros that are the solutions to the parabola or to the quadratic. And the third method is using the quadratic formula itself. The quadratic formula works all the time. You'll find that solving by factoring is a little bit tougher as the problem isn't so readily factorable. And solving by graphing without a graphing utensil might be the most time-consuming way of graphing. And the quadratic formula, it works on the strange ones, it works on the ones that are hard to graph, it works on all of them. But you do have to be able to work the formula. So solve by factoring. First, factor the polynomial. Then set each of your factors equal to 0 and solve. It is these solutions for 0 that are the solutions to the quadratic. So if we were to solve this quadratic equation, for example, first thing to notice on this one, it's not currently set equal to 0, so not all of our terms are over on the left-hand side together. You would need to move that positive 6 to the left before you begin trying to factor. So subtracting 6 from both sides, we get 2x squared minus 3x minus 5 equals 0. Now, if these are going to be handily solved by factoring, we should be able to break it into these two factors like we've been practicing. So the only way to break a 2x squared is a 2x times an x, and the only way to break a negative 5 is either going to be a negative 1 and a positive 5 or a positive 1 and a negative 5. So if you play around with those two a little bit, figure out where to plug them in, you'll find that this combination works and gives us that negative 3x in the center. So our first factor, 2x minus 5, we take that and place it equal to 0. Solve for x, add 5 to both sides, divide away the 2 on both sides, x is equal to 5/2. The second factor was x plus 1. Subtract 1 from both sides to solve for x, and we find that our other solution is going to be x is equal to negative 1. Another way to come up with factoring of a quadratic equation is called extracting square roots. If the equation is solved so that the square term is set equal to an amount or to another single term on the right-hand side, square rooting each side can find your solutions for you. So take a look at the one that I have solved out on the slide here. We had the quantity of x minus 1 to the second power is equal to 10. So notice that there's a squared item set equal to a single term. If I square root both sides, as you can see, I can get just a single x minus 1 on the left. Now on the right, notice that x minus 1 is going to be equal to the positive and negative root of square root of 10. And that's because you need to remember back, there are two roots to every number, a positive root and a negative root. So that's why you will be needing to write plus or minus the root of that other side, because both of them exist. For example, if you had the square root of 25, or if you were finding the roots of 25, 5 times 5 is 25. That's an easy one. We've done that forever. But remember, negative 5 times negative 5 is also 25. Okay, so 25 has 5 as a root and negative 5 as a root. All right, so 10 does too. You've got plus or minus the square root of 10. Now to finish solving this one out, we need to get rid of that negative 1 that's attached to the x. So adding 1 to both sides gives us that final answer of x is equal to 1 plus or minus root 10. Now, completing the square is a process that you guys worked through in Algebra 2. It again allows us to create a factorable quadratic equation out of one that maybe wasn't easily factorable. So how do you do this? I have the steps written on the slide here. I'd like you to transfer them into your notebook. First thing, you're going to write the original equation down on paper. Then step 2, move the constant to the right-hand side. Now remember, the constant is that single number term, the one that does not have a variable attached to it. So move that constant to the right-hand side. And you're also going to need to take a look and see if your x squared term has a coefficient. So if there does exist a lead coefficient, you're going to also need to divide that away. All right, I'll have 2 examples, one for each case coming up here. Step 3, take half of the b coefficient. Now remember, the b coefficient is the number attached to the x term. You're going to square that. Okay, so you've taken half of b and now you're going to square it, and you're going to add that to both sides. Then factor and write the factors as a square. All right, so a lot of steps there, a lot of language there. Let's take a look at an example and see if we can't make it make a little bit more sense. All right, so solve by completing the square. X squared minus 4x minus 1. Now notice that this one is not one that if we didn't do something different to it would be an easily factorable type of situation. So we can turn it into one of those by this process of completing the square. All right, so we were told that we needed to move our constant to the right-hand side. So adding 1 to both sides, we now have x squared minus 4x is equal to 1. Okay, so notice in this one that our b term is equal to negative 4. Okay, so our next step said take half of that. So half of b would then be negative 4 over 2. Squaring that gives us negative 2 squared, or 4. So taking half of b and squaring it results in 4. So that is what we are going to be adding to both sides of our equation. Now by doing that, the left-hand side is factorable pretty easily. A minus 2 and another minus 2. And the right-hand side is 5. Now notice x minus 2 and x minus 2 can be rewritten as a square of the x minus 2. Okay, and now we're back to extracting squares. If we take the square root of both sides here, we are going to get an x minus 2 on the left, that plus or minus the root of 5 on the right. Get rid of your 2. X will be equal to 2 plus or minus root 5. Okay, pause it if you need to. Now here's an example of completing the square if your lead coefficient is not 1. All right, so a couple of things that we're going to do here to begin. First, we will get rid of that constant. So we're going to move the negative 2 off to the right-hand side. Should have had that 0 typed there. So now we're looking at 3x squared minus 10x is equal to 2. So now right here, the 3, that lead coefficient, we need to get rid of that. So we're going to divide that front term by 3 to get rid of it. If you divide something by 3, everything in your equation needs to be divided by 3. Okay, now that's going to result in x squared out front, negative 10/3 x, and then 2/3. Okay, so now we follow that same process we did in the previous problem. B this time is negative 10/3. So half of negative 10 thirds is negative 5 thirds. Square that. And you get positive 25 over 9. So that's what we are going to have to add to both sides. So simplify here. Leave this alone for a second. Now remember, to add fractions together, you need that common denominator. So 2 thirds would actually need to be considered as 6 over 9. So we're going to 31 ninths on the right-hand side. All right, so by completing the square, we have made the left-hand side factorable into a square. We'll have an x both here and here, a negative 5 thirds both here and here. So it can be written as negative x minus 5 thirds squared is equal to 31 over 9. And we're almost done. If we square root both sides, we're going to get x minus 5 thirds on the left and plus or minus the square root of 31 over 9 on the right. Okay? Now, the square root of 31 over 9 simplifies a little bit because that denominator of root 9 can be solved. Okay, so I'm running out of room here, so I'm going to write off to the left-hand side here. But we have to add 5 thirds to both sides. So then follow me up over here. Sorry, my pen's not lining up anymore off to the right-hand side of my board. So bear with me there. Okay, so again, that square root of 9 is 3. Then notice your fractions on that right-hand side will both have denominators of 3, and we can simplify a little bit more. If you left it written like it is right here, that is not the end of the world. I'd be just fine with that as well. Okay, so even if it ends up being fractions in there, you're just going to have to keep that fraction plugging along. The completing the square works no matter how strange the numbers are. It just might be a little bit harder to take that b, cut it in half, square it, and tack it onto both sides. Your calculator is not going to be of much use with you there. You have to remember these steps with working with fractions. All right, then solving with quadratic formula. Again, remember quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm not going to sing that to Pop Goes the Weasel for you, but that is the one that Mr. Rambo used to do with you guys to that tune. Recall in that formula that a, b, and c come from the coefficients of the x squared, the coefficients of the plain x term, and then also c was just the plain constant that was in your quadratic. Now, part of that quadratic formula, the part underneath the square root symbol, is called the discriminant. B squared minus 4ac is the discriminant. Now, that provides us with a little bit of information. If we end up with a positive amount underneath our square root symbol, we can take the square root of positive amounts. So therefore, we would end up with plus or minus that square root as part of our equation, and we'd end up with two different solutions. So if the discriminant is positive, you will be finding two real solutions to your quadratic. If the discriminant is negative, you're going to end up with a negative underneath your root sign. Now, if you go back in time a little bit, memory-wise, negative roots are imaginary. Those are the ones that involve I. All right, so you're not going to get any real solutions if your discriminant ends up turning to something negative. If the discriminant ends up being 0, you will end up with one solution to your quadratic. Okay, so these pieces are going to be very helpful in helping you check to see if you are correct in your solutions. So please have this down in your notebook as well as the quadratic formula itself. So let's take a look at one of these. So in this particular one, A is going to be 3, B is 2, and C is negative 10. Now watch those negative numbers when they crop up, or those negative coefficients. Do not leave the negative sign behind. Okay, that will really mess up your formula as you're working with it. So negative b plus or minus square root b squared minus 4ac all over 2a, and let's fill it in. So the negative of b will be negative 2, b squared is 2 squared, minus 4 times 3 times negative 10 all over 2 times 3. All right, so that's all of the numbers simply plugged in. And now we begin to solve. Negative 2 plus or minus 4. Now you have negative 4 times 3 times negative 10. That's going to be plus 120 inside there. Then 2 times 3 on the bottom is 6. Continue simplifying. And that gets us to here. Now, square root of 124 is not a perfect square, so you're not going to get an integer answer here right now, but there is a little bit out of 124 that is solvable. We've talked about and we reviewed rationalizing or solving square roots as much as we can. So start thinking about the perfect squares that do exist. Do any of them go into 124? Well, 4 does. So we can break root 124 into two smaller roots. Square root of 4 and a square root of 31 would multiply together and give us that root 124. Root 4 is solvable. Gives us a 2. So now we are at negative 2 plus or minus 2 times the square root of 31 all over 6. Now just like with fractions in the past, you always reduce your fractions. We can factor a 2 or a negative 2 out. Well, we'll factor 2 out of that top part of our answer. And if we do so, we're going to have negative 1 plus or minus root 31 all over 6. And then that 2 and 6 can reduce a little bit more. So ultimately, we're going to come down to this solution. And there you go. Negative 1 plus root 31 over 3, or negative 1 minus root 31 over 3. Now, a couple of application problems in here. I believe there are 4 at the end of this section. I took a couple of them that are very commonly used application problems for us to do together before I end this video. So checkpoint at the bottom of page 106. Okay, the one above it, towards the top of the page, deals with this very similar type of situation, but that one's already worked out in the book, so I picked the checkpoint one. It says a rectangular kitchen is 6 feet longer than it is wide and has an area of 112 square feet. Find the dimensions of the kitchen. All right, so we're talking about a length and a width here. But in order to solve our equation, it would be really nice to keep it as an equation in one variable. So what I look at is we need some kind of a way to represent width and length. Because of course we all know to find the area of a rectangle, we're going to need to multiply length times width to get that area of 112. So which one, the width or length, do they give you no information toward? Okay, if it says a rectangular kitchen is 16 feet longer than it is wide, they're giving you a hint about length. You get nothing for width. That's your variable. So assign yourself a variable to width because you don't know anything about it. Now it tells you that the length is 6 feet longer than that. How would you represent 6 feet longer than W? You would take that number, whatever it is, W, and add on 6. So now you have an expression to represent both your width and your length. You can now go ahead and multiply them to find your area. So W times W, W squared. W times 6 is 6W, 112. If we bring 112 over to the left-hand side, we get a quadratic that we can look to see if we can factor or use one of our other solution techniques to solve. With a little bit of playing around, 112 does actually have some really nice factors that are going to end up giving us a 6. We can use 14 and a negative 8 to get negative 112, and 14 minus 8, of course, is going to be 6. Now, when we find our solutions of these, the factor W plus 14 equals 0 is going to yield a width of negative 14. Can you possibly have a width that is a negative 14 feet? No. That factor is discounted. You can't have a negative length or width. Okay, distance is never negative. So then look at the other factor. W minus 8 is equal to 0. So W, or the width, is equal to 8 feet. That makes sense. So now the last thing to do is figure out your length. If the width is 8 and the length is 6 longer than that, the length must be 14 feet. And there we have it. So when you're in a story problem, you know nothing about one of your items. That's your variable. And you're going to build the other stuff off of that. All right, the next checkpoint we're going to take a look at deals with the velocity formula. So I thought this might not be a bad one to go through. The formula is given to us in our textbook, and this is a standard velocity formula. In it, you need to understand what the S's mean, the T's mean, the V's mean, and so on. And that, again, is described to you right under the formula towards the top. It's the second little paragraph from the top of page 107. So in there, it tells us that S is the height of your object. It says that S sub 0, that stands for initial height. Initial height means where did it begin from? Okay, so initial height is the starting height. Then V sub 0 is initial velocity. So what was the velocity when it began? And then T is time. Okay, so if we're looking at this formula and we read the problem, it says you drop a rock from a height of 196 feet. How long does it take the rock to hit the ground? So where was the initial height of our rock? Well, we started with 196 feet high. If you dropped it, was there a velocity on the rock when it began to fall? No, the initial velocity is going to be 0. You were holding it if you dropped it. So it was not moving. It did not have a velocity. The height of the object at the time that we're supposed to be determining our time is hitting the ground. So if it's on the ground, what would you say the height of it is at that moment? You'd be correct if you said 0. So filling in our formula, we're looking for an eventual height of 0 because it's on the ground. The velocity, if we were holding it when we dropped it, was 0. And the initial height they gave us was we began at 196 feet. So this is our formula right there filled in. And so we begin to solve. 0 times t is 0. So we're looking at 0 is equal to negative 16t squared plus 196. Let's move that 16t squared to the other side. Now it's a positive 16t squared equals 196. And let's get rid of our coefficient, divide it away. So here we are at extracting the squares. To get t from t squared, we are going to square root it. To keep our equation balanced, we also have to take the roots of the other side. Now, normally, we're going to write this as plus or minus the square root of 196 over 16. But the question for you here, can time ever be negative? It can't. So in finishing out this problem, you do not need to consider both the positive and negative roots, just the positive. Now, both 196 and 16 are perfect roots. The square root of 196 is 14. Square root of 16 is 4. And that reduces to 3.5. So in 3.5 seconds, this object or this rock will hit the ground. And that is all. Now, with our visit from Mr. Van Wee the other day, I have decided to do our homework problems just a tad bit differently. Okay, so if you look at this last slide here, yes, we are done. Your assignment is going to be on page 110. Now, 8 through 24, I really think it's important that we be able to manipulate these kinds of problems and do these kinds of factoring. Then beyond that, extracting square roots, yep, that's going to come up. You need to know how to do it. Completing the square, yes, you need to know how to do it. But we probably don't need to do 8 of each one of them. Okay, so for 8 through 24, I would like you to do the evens. When you do 25 through 104, I would like you to choose a couple from each section. Now, you'd be wise to choose some odds, because again, you can check yourself in the back of the book. Okay, so take a look at some odds, and also then in the story problems, 115 to 127, work a bunch of those application problems. Can you set them up? Can you get to the correct answer? Start to get comfortable with the word problems, because you guys tend to shy away from them. So, like Mr. Van Wee is saying, if you can do them, you probably don't have to do the one right next to it, because it's probably a very simple setup and concept. So I'm going to cut you guys a little bit loose here. If it backfires on us and this first quiz that we're about to take goes really bad, I might have to rethink this, but I'm going to kind of go a little bit toward the direction that he was talking about there, where I don't need to assign, for example, all of the evens for a section for you guys to do. It's turning into a little bit much, especially this lesson, where there were, more than 127 some problems. So there you go. Hopefully you watched this at home. It did get to be a little bit longer of a video, but if you watched it at home, then you still have plenty of class time to do your problems with me. See you in the morning.